Okay, got this kind of set up here to try to reform some caps. I'm not going to go dig around in the boxes and try and find everything. We've got some things that have been sitting for a while and could use some help, so we'll work with those. We've got one that's iffy and one that's trash, and we've got a whole boxes of other stuff around here, so we'll try not to blow anything up or make too big a mess. We've got a decade box here which is set up for 2K ohms. We've got a NIXIE here, which if I turn the voltage down a little bit, the brightness will go down, so it'll come back. That's kind of crappy shot. Let me kill the lights in here. There we go. We got a number 8 there. We can still see. Kick the voltage back up. If we get it too high, there it goes. So you can see it start flashing over and down in the base there. So those usually run about 170, 160, somewhere around in there. And I don't think they fire. Yeah, they fire about 140. So they'll run about 140 to 160. 140 is about when they start to fire. And we're sitting at actually 140 right there, and it's just barely fired up. So maybe we should put a little more load on it. Make sure I twist this knob the right way and not the wrong way. Yeah. Of course, the more load you put on it, the more voltage you can. Because we're dissipating load over here. So. And that shouldn't have done anything. This does, so you can see a big difference there when we start running that up and all the way around, and that's going to cut it way down. So you need to have a little load on it. 2,000 ohms is fine. Anything between 10K and 2K will work. And I think you can go down to 1K with these and put the voltage at. You want to have some load on it. You can go to 1K here, and I think it'll fire down at the one. Yeah, we're down at 135. 140 is about where these start to fire, and you want to have about a 1K load on them. And I really don't want to do this with trying to. Here, we'll set this over here like this, so I can get in here and look at it, and we can move it from pin to pin and make the numbers change, so we can kind of check the whole thing out there. Damn it. 6, 4, 3, 2, 1. Over here, 0. Be careful with that so we don't short it. 0, 9, 8, 7, 6, 5, 4, 3, 2, 1. Anyway, there's a NIXIE tube. Now we'll turn this down because I can get zapped. And, kick it back up and play with that some more, maybe. I don't know. Like 140, 150 volts and a load on it, and you're good. And like I said, we can start here. 0, 2, 3, 4, 5. Nothing. That's probably a 6. Yep. 7, 8, 9, all the way around, and back to 0. You gotta be careful doing that 0 because you're right. I'm touching the 9 too. I don't want to touch the cathode on this or we're in trouble. But anyway, that's like 140, 150 volts. 170 tops. They get a little bright, and then after about 170 it'll start flashing over down around the cathode. Okay, that's kind of checking a NIXIE out. You want to have some sort of load. 2K resistor, 10K resistor. Anything between 2K and 10K is fine. These don't get real hot. We don't want to short that together. Now we're going to go back into our setup that we had before. Turn this down. Turn that down. get zapped. Undo this terminal down here, and I'll show you guys what I'm doing. We're gonna go down here. We're gonna take this off up here, and we're gonna take this and put it on here. And it's kind of, we're just wanting relative stuff. It's a galvanometer. The polarity doesn't matter as long as it shows the voltage. I'm cool with it. Wiring into the galvanometer, we're going into that. We've got this big long one here that comes off of the bridge, or not a decade box, which is just a resistor, so we can set it 1, 2, 3, 4 up to 10, 10 up to 100. Over here we've got 100 up to 1,000, 1,000 up to 10,000, 10,000 up to 100,000, 100,000 up to 1 million. So that's what does that go up to? 1.1 megs, 1.2 something or other megs, something like that. 1.22 or 1.111, something like that. I forget how that works. There'd be 1 meg on this one, and then 0.1 on that, but you can also add another 0.1 on that when you crank it. No, you'd be, so it's 1.11111 meg. That's what it is. Okay. Now, this one here, we want to get it on the, because it doesn't really matter. The polarity on this thing does not really matter. Just because we're just checking how fast the caps charge and discharge. We want them to read around 0, showing not much leakage. We're doing filter. Well, we can do all. We'll do all the caps. See what kind of time I've wasted. About half the time I've got. Let me reach over here and grab a capacitor or 2 or 3 or 4. Grab a few capacitors. We'll bring them over here. We're going to have to be careful with them because some of them are not rated for any higher than whatever. And I'm going to put the camera back here facing me again. And we've got, damn it. Okay, we've got a positive coming off of this. So this is going to be our positive. We want our positive clipped on here like this. We want our negative clipped on here like this. This is 600 volts. Can zap the crap out of me. We're going to put it over here on the plastic lid of this bucket down here so nothing can happen to it. We've got a piece of aluminum plate up here that we can short them out on, and we're going to start ramping the voltage up. This one's fairly new, and we've got 1K. Let's move that up to 2K. And I can say that one's fairly new, so we can see that it's charging. We're running it all the way up. Let's turn our current up. And it's been sitting around a while, so it's going to be a little weird and leaky. But we can see it's starting to come back. It's fairly new. I'm doing a really crappy job with the camera here. But when we go back the other way, now it's discharging. So as it's charging, we're reading a negative. But it's coming back. And you can watch it swing back to 0. Okay, we've got the thing maxed out now. That's 300 and it's actually gone above the 350 volts, and I think I put a meter on there. It comes up to about 375, depending on the wall volt. Sometimes I think it stops at about 375. It says 350, but that's with a load. That's with a load on it. If I turn this down until, well, there's not enough load for it to even kick in, so, or it is kicked in. No, there's no current on that. Uh-oh. I have a feeling those need cleaning. Those are just kind of cross checks. I don't think that anything really changes with those. It's a galvanometer. You know, we're passing about a ½ volt. So the question is, Is it going to swing back? Yes. So we've got a little bit of ripple there, and that's where it's probably going to be, is sitting right there at maybe 0.2 of a volt, which is pretty good because we're still running. I've turned it down and it's still up over 350. Yeah, I've got a bigger one out in the front room that goes up to 500. We don't need to do that. And if we let that sit for a while and go take off and come back later, when we get back, we'll find it sitting darn near at 0. So that's a fairly new Sprague atom. It's a 20. And we'll get it leveled out and see where it sits. Okay, that's where that would reform to if we let it sit for a long time, and that's at good lord, that's like 1/10 of a volt, which is just fine. Yeah, that's 100 millivolts. For a filter cap, you're going to be running a few of them through there. That's pretty normal. I'm going to have to be real careful here. I'm barefoot and get that off there. Now I'm going to take this up here to the aluminum plate. You saw the spark there. Now we're going to get this one here is a piece of crap, but it's fun. It is. It's a real piece of crap. I'm going to put the camera back over where you can watch me. We better hurry up here. Okay, now let's try something here, see if this thing's charged up anymore. No, this one's pretty good. Some of the older, crappier ones, let me get this thing bent down so that it's sticking into the aluminum, because I really don't want to grab this thing later and get a surprise. It sucks really bad and it hurts. So, there we go. Those are both touching the aluminum. That's what I want. We've got another one on here that's been sitting around since the 1990s. And we can see that it is slower than crap. See, we turn the power down, power's up, the needle's buried. It could probably be reformed. I've got it. Let's get it back to where we're coming on scale, if that's possible. This thing's really, the date code on it's the 1990s, so it's been hanging around on it. It's never been soldered on. It might have had some clip tabs put on it or something. Okay, I'm back on the scale. We're leaking 5 volts, and I've got 210 volts on it. And if we watch this thing closely, it is creeping back to 0 very slowly. So I'd have to go do something, come back later, and screw with it and see what happens. This one this one's a little close. I'm going to turn everything down on this. And let's get this thing here ready to... We've got our discharge plate here. Up, bang. And this one's funny because we'll set it here and count off a couple minutes. I only have I don't even have 2 minutes, but we'll let it sit there for a minute or so, and hopefully it will charge back up. That's an LCR. The date code on it is from 1995. It is 19 years old. It was made in December of 1995, so it's 19. It's been sitting around, but it says it's supposed to be 100 microfarads and 100 microfarads, and if I remember right, it was reading 100 on one and 75 on the other. Or it might have been 100. I know it was really screwed up. So I think this thing's junk. We're coming up on, let's see what happens now. Up, you see that? Another spark, and we discharged that. If I set this back down for 5 minutes and come back, it'll pop like it did before. So let's just set it upside down on there, because that thing, the way this one is, it is so bad, and the foil and the film and stuff, and there's still doing its polarizing thing to the point that if I let that sit, it will boing, and so I'm out of time.